Hello, welcome to video 4C. This is Mr. Miller, and today we're going to talk about trig functions and the chain rule. Actually, we're going to learn to use some general formulas where the the chain rule is already done for us. Let's take a look. So we're going to do a few examples here. In the first couple of examples, I'm going to do the derivative both ways, using the table and the shortcut rule so we can compare them. So here we have y equals sine of 4x squared. All right, if I was going to make a table, we would do this. And we'd write down what f, the outer function, is and what the inner function is. The inner function is 4x squared, and the outer function is sine of x. F prime would be cosine of x, and g prime is 8x. Okay, we learned that we put g of x into f prime. So we would have the derivative of y is cosine of 4x squared times g prime times 8x. And maybe we would rewrite this with the 8x in front. Like that would be done. That's perfectly fine. But we want to learn some shortcuts because we want to be able to do this quickly. These shortcuts really are the same thing. It's just the chain rule has been done for us already. So if we look at this very first rule, it says the derivative of sine of u. Sometimes that's written like this: sine of a function equals cosine of that function times the derivative of u. That's u prime. So, okay, let's see how this works. So the derivative of sine of a function, that's what we have here, sine of 4x squared, equals cosine of that function. So cosine of u times u prime. The derivative of the inside function is 2 times 4 is 8x, so times 8x. Again, we could rewrite it as 8x cosine 4x squared. So we see we get the same thing as before when using the table. But it's a pretty powerful rule because we can write the derivative in just 1 or 2 steps. All right, let's try this again. Here's another function, and I'm going to do it both ways. So we have tangent of 1 over x. This one's a little bit more difficult, but we can do this. So if we use the table to apply the general chain rule, f would be tangent of x. That's the outer function. The inside function is 1 over x. F prime would be secant squared of x. And then this one's a little tricky. Remember, we got to think of this as x to the minus 1. Its derivative would be minus 1, x to the minus 2, which we can write as minus 1 over x squared. So that's the derivative of g. All right, then we put it all together. We substitute g of x into f prime for the chain rule. So we get y prime equals secant squared 1 over x times negative 1 over x squared. And we just write that as minus secant squared x, or 1 over x, divided by x squared. That's y prime. Now, let's do the same thing using the formulas. This time we're going to be using this formula right here for tangent. So if we have the derivative of a tangent of a function, it's secant squared of that function times the derivative of the function. So here we go. So y prime, we can just write it down. Y prime would be secant squared of the function. So I've taken care of this first part, secant squared of u times u prime. And we already worked it out over here. The derivative of 1 over x is minus 1 over x squared. And that equals minus secant squared of 1 over x squared. It's the same thing we got here. We're really doing the same thing, but these formulas are kind of do part of it for us. It makes the problem shorter. So let's practice using these formulas. Okay, so we have sine of 4x. So we got to think chain rule. We have 4x is a function of x. It's substituted into sine of x. So this is a chain rule problem, but let's use the formula. Y prime equals cosine of u, so cosine 4x, times the derivative of the inside function, times 4. So we have 4 cosine 4x. That's it. Tangent of x cubed. So it's x that's being cubed, not the tangent function. So again, x cubed is the inside function, tangent is the outer. Here's the derivative. It would be secant squared evaluated at x cubed times the derivative of x cubed, which is 3x squared. Or 3x squared secant squared x cubed. Here we go. This time u is square root of x. That's the inside function. So y prime is going to be minus the sine of u times the derivative of u. So remember, square root of x is x to the 1/2, and the derivative would be 1/2 x to the minus 1/2, which is 1/2 square root of x. So here, I had to do a little work on the side. I need the derivative of square root of x, and it's 1/2 square root of x. So if I kind of put things together, I have minus 1 sine of square root of x. I guess I really don't need that 1. Over 2 square root of x. Okay, last one. Secant squared x squared minus 9. The derivative of secant is, where is it? Secant of u times tangent of u. So this y prime would equal the derivative of secant evaluated at u. Secant of x squared minus 9, tangent of x squared minus 9, times the derivative of the inside function, times 2 of x. Okay, so we get y prime equals 2x, secant x squared minus 9, tangent x squared minus 9. Okay, so just, once you practice these, you won't even think about it. Okay, I got 2 others. Sometimes we have trig functions inside of trig functions. And this is not really that bad. We just keep doing what we're doing. So the derivative is going to be cosine, evaluated here, times the derivative of the inside function, minus sine of x. So we get y prime equals minus sine of x, cosine of cosine of x. Okay, crazy but true. Here we go. Here's a weird function, tangent of sine of x. Sometimes these functions we practice taking derivatives on are really crazy. This is a graph of that down below. It's kind of an interesting graph. It oscillates really, really fast around certain points here. And that pattern keeps repeating. Anyway, tangent of sine of x. So y prime would be the derivative of tangent, which is secant squared, evaluated at the function, whatever that is, sine of x, times the derivative of the inside function. That'd be cosine x. So we got secant squared of u times u prime. But this time u is sine of x. Okay, I'm just going to leave it like that. These are a little bit more complicated problems. But one thing at a time. So we see that the outer function here is sine of x. And the only reason why this is a little bit more difficult, because when we take the derivative of the inside function, it's a composition of functions itself. We're going to need a chain rule for that. But like I said, start with the same thing we always do. Derivative of sine is cosine. It's evaluated at u. Times, now I need the derivative of this thing. Let's work that out down here. So square root of 3x squared plus 1 is 3x squared plus 1 to the half, and its derivative would be 1/2 3x squared plus 1 to the minus 1/2 times the derivative of the inside. I'm using the power rule that we learned in the last video. 1/2 times 6 is 3. We have x. We're going to put this in the denominator. Okay, so all of that was to find the derivative of this. We have cosine evaluated here times the derivative of that, which we worked hard to find, is 3x over square root of 3x squared plus 1. All right, I'm going to leave it like that. So sometimes you got to do a little work on the side. We get to a point where we know we need a derivative of something complicated. Use a little scratch paper. All right. We're going to take the tangent of x over x plus 2. Already, I see what the trouble is. The trouble is not taking the derivative of the tangent. It's the inside function. And we need the quotient rule for that. So, like I said, start the way we normally start. Y prime is secant squared of the function times the derivative of the function. Okay, let's go down here and do a little work. X over x plus 2. Well, we need the quotient rule for this. So the quotient rule is g f prime minus f g prime over g squared. So g would be x plus 2. It's not a bad quotient rule. Times f prime, which is 1, minus f, which is x, times g prime, which is 1, all over g squared. All right, we have an x, a 2 minus x. I think we just have 2 left over x plus 2 squared. And that's what we got to put here. So we were doing secant squared of x over x plus 2 times its derivative, which now we know is this. Done. Okay, let's try these. These are a little different. We have to keep straight the exponents here. So y equals, I'm going to rewrite it, cosine of 7x all squared. Okay, so I haven't done anything yet. I just rewrote it. But this makes it kind of clear what we have to do. The outermost function is the squaring function. The next function is cosine, and the innermost function is 7x. All right, so let's start. Y prime equals 2 times cosine 7x to the 1 less power times the derivative of the inside. We know how to do this now. It would be minus sine 7x, so times minus sine 7x, times the derivative of the inside, times 7. So really, we kind of have the chain rule twice. 2 times the inside function times its derivative. But when we take the derivative of cosine 7x, we need the chain rule. Minus sine 7x times 7. When we put this all together, we have a minus 14 cosine 7x sine 7x. Okay, let's rewrite this one as a power. We have y equals, it would be sine of 2x to the 1/2. So we're going to apply the general power rule. Y prime would equal 1/2 sine 2x to the minus 1/2 times the derivative of what's inside. It would be cosine of 2x times the derivative of 2x. So it would be cosine 2x times 2. That's the derivative of this. We're just doing what we did in the first few slides. Derivative of sine is cosine. Evaluate at 2x times its derivative. 1/2 and the 2 cancel, so we can keep this in the numerator. And the denominator is going to go square root of sine 2x. Alright, what else is there? Let me see. This is the very end here, so let's work through these. So this one requires the product rule. So that's where we're going to start. We have x times cotangent 2x. So the product rule is f prime g plus f g prime. So we have y equals, f prime would be 1, g is cotangent 2x, plus f, which is x, g prime is the derivative of this guy, which is what we're doing today. That would be minus cosecant squared 2x times the derivative of the inside, times 2. We use the chain rule there. Okay, so we get cotangent 2x plus, actually minus 2x cosecant squared 2x. Alright, here's our last example. Okay, so we have y equals sine of x over x squared. We need the quotient rule for this. So let me write that down again. It's g f prime minus f g prime over g squared. All right, so g is x squared. F prime would be cosine x minus f, which is sine of x, times g prime, so times 2x, divided by g squared. X squared squared is x to the fourth. We're kind of done. The only thing we can do is cancel an x from every term. So we would have y prime equals x cosine x minus 2 sine of x over x to the third. Remember, we can cancel factors. X is a factor of the numerator. We can factor it out. It's actually the greatest common factor. All right, that was a lot. Time for you to work on some. So find the derivative of the following functions. The first four kind of apply the rule. They're more basic. They only involve applying the rules over here. So for problem number 2, you're going to have to rewrite the functions. So here, write this as y equals parentheses sine of 3x squared and take the derivative. On this one, write this as y equals parentheses sine of 2x to the 1/2 and take the derivative. Finally, on the last one, start with the product rule and take the derivative of that function. Good luck.